covered what is stereoisomerism, right? In the stereoisomerism part, you have two types of isomers. One is your geometrical isomers and one is your optical isomers. Geometrical isomers is also known as your cis-trans isomers, right? And optical isomers, which have a carbon atom, which have four different groups, which is attached to it, is called a chiral carbon or the asymmetric carbon atom. Okay. So, have we covered this slide? More than one chiral center?
Yes, I think so.
Okay. Check it in your notes. Have I explained that organic molecules they can contain more than one chiral carbon atom, more than one chiral center. If there are two asymmetric carbon atoms, then each of its chiral center it will rotate the plane of polarized light. So in one case there will be two optical isomers, and if there's two chiral center, then there will be four possible optical isomer. Okay. I don't think I've explained this. Please check it in your notes. For example, look at this molecule. This is your cyclohexane. So in cyclohexane, all the carbon atoms are bonded to two hydrogen atoms. So there is no chiral center. If this is my cyclohexane, then all the carbon atoms are attached to the two hydrogen atoms. So there is no chiral center, right? Because no four groups are different. But when you start substituting other groups or atoms to replace hydrogen atoms, but when you substitute this hydrogen with a OH, and when you have substituted this hydrogen with NH2 group, then there is a possibility of asymmetric carbon atom. This is also asymmetric carbon atom, chiral carbon atom, because of four different groups attached to it. This is also asymmetric carbon atom because of four different groups attached to it, right? In a cyclic molecule shown, we have a hydroxyl group and an amine group which is introduced into the ring. Let's consider the carbon atom bonded to the hydroxyl group first. Okay, let us consider this carbon atom first. This carbon atom is also bonded to a hydrogen atom. It is not shown in the skeletal formula. In the skeletal formula, we do not show the carbon-hydrogen bond, but it is there. Okay, in the below the plane of paper. The other two groups bonded to it, making up its four single bonds, they are not the same. It's this group is what? CH2, 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 NH2, and here this group is CH, NH2, right? So four groups are not same. I'm talking about this carbon atom. The four groups which is attached to this carbon atom are not the same. So this is also chiral center and this is also chiral center. So it have two chiral centers. If it is having two chiral centers, and if you want to calculate the number of optical isomers, so to calculate the number of optical isomers, you have to see if there is one chiral center, then you have two optical isomers. Two optical isomers. If there are two chiral centers in this compound, so you have 2 raised to the power n. N is your number of chiral centers, that is 4. We have 4 chiral centers in this. Okay. So what I want to tell you here is that organic molecule, they can contain more than one carbon atom. It's not necessary that they contain only one chiral center. If there's one chiral center, then they have two optical isomers. One will rotate the plane of polarized light to the clockwise direction, and one will rotate the plane of polarized light to the anti-clockwise direction. Right? But if they have more than one carbon atom, so you have to use the formula 2 raised to the power n to calculate the number of optical isomers. Please write down this.
I'm also done.
This is your homework question. Draw the state formula and label the cis-trans isomers of butene. Draw the cis-trans isomers of 1-bromo-2-cyclobutane. And this shows exhibit optical isomerism because all the four groups are different. Draw the 3D formula of both optical isomers. You have to do it at your home.
I'm done.
So this topic is complete isomerism. Next topic is types of organic reactions and reaction mechanisms. So like all the chemical reactions, organic reactions involve the breaking and making of chemical bonds. Obviously the bond is break and the bond is formed in a chemical reaction. There are two ways in which a covalent bonds can be break. One is your homolytic fission and one is your heterolytic fission. So what is homolytic fission and what is heterolytic fission? We'll discuss in the next slides. We have to remember that whenever a chemical reaction is happening, then there is involvement of breaking of bonds and the formation of bonds, as we have studied in chemical energetics chapter. There are two ways in which covalent bonds can break. One is homolytic fission. Fission means breakage. And the second is heterolytic fission. If I'm having a bond HF, so this bond means what? It is a covalent bond. How many electrons does this bond have?
One.
It is forming a bond. So two electrons are involved here, right? In one bond, you always have 2 electrons. In 2 bonds, you always have 4 electrons. In 3 bonds, you always have 6 electrons. So in homolytic fission, how this bond is broken, we'll see in the next slide. First of all, write down the this thing, types of organic reaction and reaction mechanics.
I'm done.
Homolytic fission. Homolytic fission means what happens in homolytic fission. For example, in this case, let us understand this with the help of hydrogen chloride. In this type of bond breaking, both the atoms at each end of the bond leave with 1 electron from the pair that formed the covalent bond. So this is your electron dot structure of HCl. I hope you know how to make it. Chlorine have 7 electrons in its valence shell. Hydrogen have 1 electron. Okay. Then what happens in homolytic fission? I told you how many electrons does this bond contains? 2 electrons. So in homolytic fission, you represent it like a fish-headed arrow. One electron is taken up by hydrogen and one electron of this is taken up by chlorine. Okay, that means there is equal distribution of electrons in homolytic fission. Here, the species produced when a bond breaks homolytically are called free radicals. So this H dot plus Cl dot, they are known as my free radicals. We can show the formation of free radicals by using this equation. So these are free radicals. Free radicals means they have an unpaired electron, which is represented by the dot, and these are very reactive in the chemical reactions. So one electron is taken up by hydrogen and one electron is taken up by chlorine. Okay, equal distribution is known as your homolytic fission.
I'm done.
Okay.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Done writing?
Yes.
Okay. So in this radical reaction, there are three steps in a free radical reaction. First is known as your initiation step, second is known as your propagation step, and third is known as your termination step. In initiation step, the formation of free radicals to start a reaction off is happening. And in propagation step, the reaction starts. It steps in a mechanism which regenerate more free radicals. And in termination step, it is the final step. It terminates now the reaction when two free radicals meet and form a product molecule. So there are three steps in a free radical reaction. Initiation step, where the formation of free radicals happen. Then the propagation step, where there is a regeneration of more free radicals. And the termination step, which is the final step in a mechanism when two free radicals meet and form a product molecule. For example, H dot and Cl dot meet and form HCl. So these three steps you have to remember.
I'm done. I'm also done.
Now in heterolytic fission, it is here uneven breaking will happen. It is a second type of bond breaking which involves uneven breaking of covalent bond. So in heterolytic fission, for example, in HCl, what happens? Both the electrons, here we have how many electrons? 2 electrons. So both the electrons are taken up by the most electronegative element, which is chlorine in this case. So this is your heterolytic fission. It is represented by a full arrow. Okay, so you have H plus because of hydrogen has lost its electron, so it becomes positively charged, and chlorine have gained both the electrons, so it becomes negatively charged. Okay, so there's a formation of cation and anion in heterolytic fission, and there's a formation of free radicals in the homolytic fission. Okay, so complete transfer of electrons takes place towards the most electronegative atom in the heterolytic fission.
I'm done. I'm also done.
So we can show this type of bond breaking in an equation. Here a small curly arrow shows the moments of a pair of electrons, and in the homolytic fission you are drawing two fish-headed arrows. So in this, the more electronegative atom will have both the electrons. For example, CH3Br, Br is more electronegative, so it will have a Br negative and CH3 positive.
I'm done.
Yeah.
I'm also done.
So in this case, as the bond breaks, the bromine atom takes both shared electrons, forming a bromide anion, which is your negatively charged ion. This leaves the methyl group one electron short because this electron is taken up by bromine, so resulting in the formation of positively charged ion because of the loss of one electron. So this type of alkyl ion is called a carbocation. So this CH3 plus is called a carbocation, right? And Br minus is known as anion. Why it is called carbocation? Because there is a positive charge on the carbon atom, right? This Br minus, it is not carbon ion because here there is no carbon atom. It is only anion.
I'm done. I'm done.
Okay, now I'm giving you some molecules. You have to write down the UPSC names that. You have to tell me the UPSC name of these three compounds. Solve it.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Okay, so what is the name of first compound? Let's give it a try. What is the name of first compound? Your counting will start from where? 1, 2, 3, 4, 5, 6, right? Then 2-methyl will come first or 3-ethyl will come first?
3-ethyl.
Yes. Then say the entire name 3-ethyl, then
2-methyl.
2-methyl, then
18.
there are 6 carbon atoms. Is it heptane or hexane?
Hexane.
3-ethyl, 2-methyl hexane. Okay. Very good. Come on, let's solve question number 2 also. What is the IUPAC name of this compound?
2-ethyl 3-propyl pentane.
What? What is? Say it again.
3-propyl 2-ethyl pentane.
No, you have first rule is that you have to select the longest carbon chain in continuity. Longest carbon chain is of 7 carbon atoms. 1, 2, 3, 4, 5, 6, 7. So it should be heptane. Now just add the super prefixes. What should it be the prefixes? Four ethyl, right? At 4 position we have a ethyl group, and at 3 position we are having a methyl group. So 4 ethyl 3 methyl heptane is the IUPAC name of this compound. Okay, is it clear?
Yes.
So now tell me the IUPAC name of third compound. One, because counting will start from where the branching is nearest. So here there is 2 branching, so counting will start from here. 1, 2, 3, 4, 5. So it should be pentane. Now tell me the prefix. What are the groups which are attached to it?
2,2,4 trimethylpentane.
Yes, 2,2,4 trimethylpentane is the correct answer of this question. So this is your IUPAC names. We'll practice more IUPAC names in every sessions from now. Okay. So let's end this session here only. In the next class, we are going to cover about the stability of carbocations, and then we'll study about the organic reactions. So thank you